21st September 1942. Seattle, Washington, Boeing Aircraft Company, Colonel Curtis Emerson LeMay assumes command of 21st Bomber Command in January 1945. The number that matters is 31,850 feet, the B-29 service ceiling. The Pacific Air War turns on a single axis, altitude. High above the ocean, where air thins and engines gasp, control of the vertical frontier decides victory. On 21st September 1942, the Boeing B-29 rolls onto the runway at Seattle Boeing Field. Its four Wright R-3350 duplex Cyclone engines roar, each fitted with a General Electric B-11 Turbo-Supercharger. These exhaust-driven compressors, working in tandem with engine-driven superchargers and intercoolers, force dense air into 18-cylinder radials, sustaining power where most aircraft falter. The bomber climbs steadily, piercing 30,000 feet, entering a low stratosphere where Japanese fighters struggle to pursue. This is no ordinary machine. Pressurized crew compartments shield men from the biting cold remote-controlled turrets, guided by a central fire control system, promise precision strikes from heights that render anti-aircraft guns nearly impotent. The U.S. Army Air Forces, pushing the very heavy bomber program since 1939, authorizes quantity production before this first flight, staking everything on a design to strike Japan industrial core. The B-29 engineering is a calculated triumph over physics. Each Wright R-3350 engine delivers 2,200 horsepower at takeoff, a brute force tempered by complexity. The General Electric B-11 Turbo-Superchargers are the true innovation, harnessing exhaust energy to drive compressors that maintain manifold pressure at altitudes above 25,000 feet. Unlike purely mechanical superchargers which sap engine power, the turbo system extracts energy from waste gases, preserving thrust for sustained climbs and long-range cruises. This allows the B-29 to operate at a service ceiling between 31,850 and 33,600 feet, outpacing the climb rates of most Japanese interceptors. Its combat range is approximately 3,250 miles, with a light bomb load about 5,000 pounds. With a 20,000-pound bomb load, the practical range was far shorter. Pressurized compartments create shirt-sleeve conditions for the 10 or 11-man crew, eliminating the need for oxygen masks and heated gear except as backup. The central fire control system coordinates 4 remote-controlled turrets, 2 upper, 2 lower, plus a manned tail turret, each mounting twin 50-caliber machine guns to track and engage targets with mechanical precision, compensating for the thin air effect on ballistics. Yet the B-29 is not without flaws. Early R-3350 engines run hot, prone to fires that can cripple a mission. Turbo-supercharger maintenance is a ground crew nightmare, requiring meticulous calibration to avoid compressor stalls. Fuel management at altitude demands constant vigilance, as crews balance lean mixtures to stretch range against the risk of engine strain. By June 1944, Operation Matterhorn launches the first B-29 raids from bases in India and China, testing the aircraft extreme range. These missions, staged from distant airfields like Kharagpur, reveal the logistical strain of supplying fuel and bombs over the Himalayas. The capture of the Marianas, Saipan, Tinian, and Guam in mid-1944 changes the equation. New airfields carved from coral and jungle position B-29 seconds within striking distance of Japan home islands. Command shifts from Brigadier General Kenneth B. Wolfe to Major General Curtis Emerson LeMay, first for 20th Bomber Command, then for 21st Bomber Command. LeMay's relentless focus on operational efficiency sharpens the campaign, turning the B-29 into a weapon of attrition. Japanese air defenses, watching contrails streak across the sky, face a grim reality. Their fighters, like the Nakajima Ki-44 Shoki, climb hard, but lose agility above 25,000 feet. The Mitsubishi J-2M Raiden, designed for bomber interception, fares little better without turbo-superchargers in most variants. Anti-aircraft guns, while theoretically capable of reaching high altitudes, struggle with fire control systems unable to track fast-moving targets at extreme heights. Japanese pilots cursed sluggish controls at 30,000 feet, chasing untouchable B-29 seconds. The number that matters is 31,850 feet. Raids often begin near this altitude. There was no standard engine overhaul after 50 hours. At full throttle, early R-3350 reliability issues did drive heavy maintenance burdens, but not a fixed 50-hour full throttle overhaul rule. While Key, 44 seconds, and J2Ms could reach around 30,000 feet, their performance and handling degraded there, without turbo-supercharging, narrowing interception windows. Each mission tests the turbo-superchargers' reliability as ground crews labor to keep the complex systems operational. The aircraft range and altitude are not mere specifications. They dictate the rhythm of the campaign, stretching Japan defenses to their breaking point. The B-29, a machine born of engineering audacity, carries the war to new heights where only the prepared can follow. The B-29's dominance in the stratosphere rests on the Wright R-3350 duplex Cyclone, a radial engine pushed to its limits by turbo-supercharging. Each of the 4 engines mounted on the bomber's wings generates 2,200 horsepower at takeoff, driving the aircraft through thin air. The General Electric B-11 turbo-supercharger, a marvel of wartime engineering, uses exhaust gases to spin a compressor, forcing dense air into the 18-cylinder engine. This system, paired with an engine-driven supercharger and intercooler, maintains manifold pressure at altitudes where unboosted engines falter. The result is sustained power at 31,850 feet, allowing the B-29 to cruise above most Japanese defenses. The aircraft's design integrates these power plants with a sleek airframe optimized for high-altitude efficiency, carrying about 5,000 pounds over about 3,250 miles, with 20,000 pounds. The Twent practical range was far shorter. Development of the R-3350 begins in 1937, but early versions suffer reliability issues. Overheating plagues the cylinders and oil leaks persist during long missions. By 1944, operational deployment reveals the engine's growing pains. Fires erupt from overtaxed components, forcing emergency landings. Ground crews working under pressure in the Marianas did not follow a standard 50-hour full-throttle overhaul rule. Early reliability issues did impose heavy maintenance demands. The turbo-supercharger itself demands precision maintenance, as compressor blades can seize if tolerances drift. Yet the system's efficiency is unmatched. Unlike mechanical superchargers which drain engine power, the B-11 extracts energy from exhaust, preserving thrust for climb and cruise. This allows the B-29 to maintain 357 miles per hour at high altitude, outpacing interceptors struggling in thin air. The airframe complements this power. Pressurized compartments, a first for bombers, maintain sea-level conditions for the crew, reducing fatigue on missions lasting 12 to 15 hours. The central fire control system, linking 4 remote turrets, 2 upper, 2 lower, plus a manned tail turret, calculates lead and elevation for 50 caliber guns, effective against fighters losing agility above 1,000 feet. Japanese defenses built for lower altitude threats strain to adapt. The Nakajima Ki 44 Shoki, a high-climb interceptor, reaches around 30,000 feet, but performance and handling degrade there without turbo-supercharging. Anti-aircraft guns, limited by primitive fire control and fusing, rarely score hits at the B-29's operating ceiling. The constraint was fire control lag at 30,000 feet. This altitude advantage shapes early raids launched from Saipan and Tinian starting in November 1944, targeting Japan's industrial centers. Japanese pilots cursed fleeting glimpses of B-29 seconds untouchable above their ceiling. The engineering triumph is not without cost. Fuel management remains critical, as lean mixtures stretch range but risk engine damage. Crews monitor gauges, obsessively adjusting throttle and mixture to balance performance and endurance. The Marianas bases, still under construction in late 1944, strain to supply fuel bombs and spare parts for hundreds of B-29 seconds. Major General Curtis Emerson LeMay, now commanding 21st Bomber Command, drives relentless improvements in maintenance and sortie rates. His focus sharpens the campaign, ensuring more aircraft reach the target. The B-29s range 3,250 miles with a light bomb load, enables strikes on Tokyo from Tinian, a distance that stretches Japanese defenses thin. Each mission tests the Turbo-Superchargers' limits, as the system's complexity challenges mechanics under tropical heat and coral dust. The altitude advantage, hard-won through engineering, sets the stage for a strategic campaign Japan cannot counter directly. The Pacific stretches vast and unforgiving, a theater where range and altitude dictate survival. In June 1944, Operation Matterhorn launches the B-29's first combat missions from bases in India and China, targeting Japan's industrial heart. Kharagpur, India, and Chengdu, China, serve as staging points, but the logistics are brutal. Fuel and bombs must cross the Himalayas, a supply line nicknamed the Hump, where C-46 transports battle turbulence and icing. With a light bomb load of about 5,000 pounds a B-29 could make about 3,250 miles round trip with 20,000 pounds. The practical range was far shorter. The General Electric B-11 Turbo-Superchargers maintain power at 31,850 feet, but engine reliability remains a concern. Overheating, R-3000, 350 seconds imposed heavy maintenance burdens, but there was no standard 50-hour full-throttle overhaul rule. Brigadier General Kenneth Barnett Wolfe commands 20th Bomber Command during Matterhorn, orchestrating raids from distant bases. The B-29's range, roughly 3,250 miles, with a light load stretches to Japan but strains air crews and ground support. Missions from China launched from forward fields like Chengdu face persistent cloud cover and high-altitude winds degrading bombing accuracy. Japanese defenses, though limited at 30,000 feet, capitalize on these errors. Anti-aircraft guns struggle to track fast-moving bombers, but interceptors like the Nakajima Ki-44 Shoki climb to engage only to falter in thin air. The Turbo-Superchargers give B-29 seconds an edge, sustaining 357 miles per hour at altitude, outpacing most pursuers. The capture of the Mariana Saipan, Tinian and Guam in mid-1944 transforms the campaign. New airfields hacked from coral and jungle position B-29 seconds within 1,500 miles of Tokyo. Major General Curtis Emerson LeMay takes command of 20th Bomber Command in August 1944, then 21st Bomber Command in January 1945, replacing Major General Haywood S. Hansel Jr. LeMay's focus on efficiency doubles sortie rates. Tinian's North Field, with its 4 parallel runways, becomes a B-29 hub, launching raids by November 1944. The aircraft's pressurized compartments ease crew fatigue on 12-hour missions, while remote turrets mounting twin 50-caliber guns deter interceptors losing performance above 25,000 feet. Fuel consumption stabilizes at altitude, but crews must lean mixtures carefully to preserve range. Japanese pilots cursed contrails, marking B-29 seconds beyond their reach. The shift to the Marianas cuts reliance on the hump, freeing resources for sustained operations. Each B-29 carries 10 to 11 crew members, managing complex systems under pressure. The central fire control system, computing lead for turrets, proves effective against climbing fighters like the Mitsubishi J-2M Raiden, which struggle around 30,000 feet without turbo-superchargers. Japan's anti-aircraft batteries, limited by outdated fire control, rarely hit targets at 31,850 feet. Yet high-altitude winds, later identified as the jet stream, scatter bombs, reducing precision against factories and docks. LeMay, analyzing raid data, notes the gap between design and results. The B-29's altitude advantage holds, but weather and distance blunt its early impact. The campaign's rhythm shifts toward relentless pressure as Marianas bases enable daily strikes by early 1945. High above the Pacific, B-29 crews operate in a realm of cold precision and constant vigilance. The bomber's pressurized compartments maintain sea-level conditions, allowing shirt-sleeve comfort at 31,850 feet. Oxygen masks and heated gear, standard in earlier bombers, remain stowed unless systems fail. Each aircraft carries 10 to 11 men, pilots, navigators, bombardiers, engineers, radio operators, and gunners. The flight engineer's panel, dense with gauges, demands relentless attention to the Wright R-3350 engines. Turbo-superchargers sustain power, but fuel mixtures must be leaned carefully to stretch the 3,250-mile range. A miscalculation risks engine strain or mission abort. Crews train for 12-hour flights, managing fatigue, while monitoring manifold pressure and cylinder temperatures. The Central Fire Control System, a technological leap, coordinates 4 remote turrets, 2 upper, 2 lower, plus a manned tail turret, each armed with twin 50-caliber machine guns. Gunners seated in pressurized stations track targets through optical sights with computers adjusting for altitude and speed. Japanese interceptors like the Nakajima Ki-44 Shoki climb to around 30,000 feet, but lose agility in thin air. The Mitsubishi J-2M Raiden, built for bomber interception, struggles similarly without turbo-superchargers. At 30,000 feet, B-29 gunners hold the advantage, their turrets effective against sluggish pursuers. The system's precision compensates for the changes in drag and trajectory at altitude, not a reduction in bullet muzzle velocity. Crews report confidence in the setup, though constant drills ensure readiness for rare high-altitude engagements. Japanese pilots cursed B-29 seconds weaving through clouds untouchable at 30,000 feet. Maintenance remains the hidden battle. Turbo-superchargers, critical for high-altitude performance, had no standard 50-hour overhaul rule, early R-3350. Reliability issues imposed heavy and frequent maintenance instead. Ground crews on Tinian and Saipan, working in coral dust and tropical heat, battle to keep engines reliable. Oil leaks and compressor stalls plague early missions, forcing emergency landings. The R-3350 complexity demands skilled mechanics and spare parts are scarce in 1944. Major General Curtis Emerson LeMay, commanding 21st Bomber Command, pushes for standardized procedures to boost sortie rates. His oversight ensures more B-29 seconds reach Japan, each carrying up to 20,000 pounds of bombs, with typical loads reduced on long-range Marianas raids to balance fuel and distance. Navigators plotting courses over featureless ocean rely on celestial fixes and dead reckoning, as radar is limited over water. The human element shapes outcomes. Pilots adjust to the B-29 heavy controls, sluggish at altitude but stable in cruise. Bombardiers, using the Norden bombsight, struggle with high-altitude winds that scatter payloads. Accuracy suffers against small targets like factories despite the aircraft design for precision. Crews note the psychological strain of long missions isolated in the stratosphere, with only the drone of engines and the threat of flak or fighters. Yet the B-29 altitude advantage enabled by turbo-superchargers keeps losses low in 1944. Japan defenses, stretched thin, cannot sustain effective high-altitude interceptions. The campaign builds momentum as LeMay refines tactics to exploit the aircraft range and ceiling, pressing Japan industrial centers relentlessly. Japan's air defenses scramble to counter the B-29's stratospheric advantage, but engineering and tactics lag behind. The Nakajima Ki-44 Shoki, a dedicated interceptor, uses a single-stage 2-speed supercharger and can reach around 30 to 36,000 feet, though performance drops at those heights, but its performance drops sharply above this altitude. The Mitsubishi J-2M Raiden, designed specifically to engage high-altitude bombers, could also approach the low to mid 30,000-foot band in operational forms without turbo-superchargers. Reaches similar heights, but lacks turbo-superchargers in operational variants. Without the exhaust-driven boost of the B-29's General Electric B-11, Japanese fighters struggle to sustain speed or maneuverability at 31,850 feet. Pilots report sluggish controls and fading engine power, unable to close with B-29 formations, cruising at 357 miles per hour. Night interception, critical for countering raids, remains limited by rudimentary radar and poor coordination. Ground-based defenses fare no better. Japan's heavy anti-aircraft guns, like the Type 88 75mm, can theoretically reach 30,000 feet, but fire control systems are outdated. Tracking fast-moving B-29 seconds at extreme altitudes, strains, analog predictors, and proximity fuses are scarce. Flak bursts, often inaccurate, were less effective at the B-29's typical operating altitudes, but not entirely negligible. The constraint was fire control accuracy at 30,000 feet. Japan's industrial base, battered by early 1945, cannot produce advanced systems fast enough. Experimental projects like the turbo-supercharged Nakajima Ki-87 or the high-altitude Ki-94-2 show promise but remain prototypes, never reaching operational squadrons before the war's end. Japanese pilots cursed B-29 seconds, gliding beyond their gun sights at 30,000 feet. Major General Curtis Emerson LeMay, commanding 21st Bomber Command, exploits these weaknesses. From Tinian and Saipan, B-29 seconds launched daily raids by February 1945, with up to 20,000 pounds possible on short-range sorties, while long-range Marianas missions typically carried much lighter loads to preserve range, each carrying up to 20,000 pounds of bombs over 3,250 miles. The aircraft's turbo-superchargers, though maintenance-intensive, enable sustained operations at altitudes where Japan's defenses are ineffective. LeMay's crews trained to maximize range-lean fuel mixtures to stretch missions, though this risks engine wear. Ground crews battling corrosion and heat did not follow a standard 50-hour high-power overhaul rule. Early R-3350 issues drove heavy, frequent maintenance instead. Overhaul R-3350 engines after 50 hours of high-power use, ensuring sortie rates climb. Japan's airfields stretched across the home islands lack the concentrated defenses of European theaters, diluting their response. The high-altitude campaign, however, reveals flaws. Powerful winds later identified as the jet stream blow at 100 to 200 miles per hour above 25,000 feet, scattering bombs and reducing accuracy against precise targets like factories. Cloud cover over Japan, persistent in winter, obscures aiming points, forcing bombardiers to rely on radar with mixed results. LeMay, analyzing post-mission reports, notes the gap between the B-29's design for precision and its real-world impact. Japan's defenses, though limited, capitalize on these errors, protecting key industrial sites longer than anticipated. The turbo-superchargers' altitude advantage remains, but the campaign's effectiveness hinges on adapting to these environmental constraints. The B-29's high-altitude promise, built on turbo-supercharged power, meets an invisible adversary above Japan, Chi the jet stream. At 31,850 feet, winds howl at 100 to 200 miles per hour, not fully anticipated by planners in late 1944. These gales tearing across the Pacific scatter bombs far from their targets. The Norden bomb site, a marvel for daylight precision, falters when clouds blanket Japan's industrial centers. Radar bombing used as a fallback lacks the accuracy to hit factories or docks. B-29 crews, flying long-range missions of about 3,000 to 3,250 miles from Tinian, with light bomb loads, report frustration as payloads miss by hundreds of yards. The turbo-superchargers sustain power at altitude, but nature's fury undermines the campaign's core premise. Major General Curtis Emerson LeMay, commanding 21st Bomber Command, studies raid reports in early 1945. The B-29's service ceiling, 31,850 to 33,600 feet, keeps losses low. Japanese interceptors could reach these heights, but were less effective there. Yet the jet stream's discovery forces a reckoning. High-altitude raids designed for precision deliver inconsistent results against Japan's dispersed industrial targets. LeMay, known for relentless analysis, recognizes the need for a tactical shift. The aircraft's range and altitude, enabled by General Electric B-11 turbo-superchargers, remain unmatched, but accuracy demands a new approach. Engine maintenance persists as a bottleneck, but there was no standard 50-hour high-power overhaul rule. Early R-3350 issues drove heavy and frequent maintenance instead. Japanese pilots cursed distant B-29 seconds, lost in jet stream turbulence. On the night of 9th to 10th March 1945, LeMay pivots. He orders low-altitude incendiary raids at 5,000 to 7,000 feet, stripping most defensive guns, often retaining the tail turret to carry more bombs. Tokyo's urban industrial sprawl, built of wood and paper, becomes the target. The shift sacrifices altitude for accuracy, exploiting Japan's vulnerability to fire. Turbo-Superchargers, less critical at low levels, still ensure engine reliability during long missions. The raid ignites a firestorm, destroying 16 square miles of Tokyo and proving the tactic's devastating effect. Crews no longer battling jet stream winds achieve tighter bomb patterns. The campaign's rhythm changes overnight as LeMay redirects B-29 seconds to burn Japan's cities, bypassing the precision myth. The pivot to low-altitude incendiary raids redefines the B-29's role in the Pacific War. On 9th to 10th March 1945, 279 B-29 seconds, stripped of most defensive guns, fly at 5,000 to 7,000 feet over Tokyo. Each carries around 12 to 16,000 pounds of incendiary bombs on this mission. The General Electric B-11 Turbo-Superchargers, though less critical at low levels, ensure steady power for the roughly 3,000-mile round trip from Tinian. The raid ignites a firestorm, consuming 16 square miles of Tokyo's urban industrial core, killing approximately 100,000 people and destroying countless factories. Major General Curtis Emerson LeMay, commanding 21st Bomber Command, commits to this strategy, targeting Japan's wooden cities with relentless waves of firebombs. The shift sacrifices the B-29's high-altitude advantage for devastating effect. At low altitudes, jet stream winds no longer scatter bombs, and cloud cover becomes less disruptive. Bombardiers using visual aiming achieve tighter patterns against sprawling urban targets. Japanese defenses, optimized for high-altitude interception, are caught off guard. The Nakajima Ki-44, Shoki and Mitsubishi J-2M Raiden, already limited above 25,000 feet, struggle to engage fast-moving B-29 seconds at night. Anti-aircraft guns, ineffective against low, swift targets, fail to adapt. Japanese pilots cursed firelit skies B-29 seconds untouchable in the dark. The campaign's intensity surges with 5 major incendiary raids by May 1945, leveling key cities like Nagoya, Osaka, and Kobe. The B-29's range about 3,000 to 3,250 miles, with a light incendiary load, enables sustained operations from the Marianas. Ground crews battling engine wear had no fixed 50-hour overhaul rule. Early R-3350 issues drove heavy and frequent maintenance. LeMay's focus on sortie rates ensures near-daily massed raids that overwhelm Japan's depleted air defenses. By August 1945, the campaign culminates in atomic strikes on Hiroshima and Nagasaki, delivered by B-29 seconds at 31,000 feet, leveraging their turbo-supercharged ceiling for precision. Japan's industrial capacity already crippled by firebombing collapses. The surrender on 15 August 1945 ends the war with B-29 seconds flying over Tokyo Bay during the formal ceremony on 2 September. The B-29's technical legacy endures beyond victory. The General Electric B-11 Turbo-Supercharger, perfected under wartime pressure, advances turbine practice that feeds into post-war gas turbine development. The R-3350, despite early flaws, becomes a benchmark for high-altitude piston engines, powering later aircraft like the Lockheed Constellation. The B-29 itself, designed for 31,850 feet, proves versatile enough to dominate at low altitudes, a testament to its engineering. LeMay's tactical shift, adapting to Japan's unique vulnerabilities, cements the aircraft's role as a decisive weapon. The Pacific War, shaped by the B-29's range and power, marks a turning point in aerial warfare, where technology and doctrine merge to devastating effect.